the attack at all, even for a short while? This question, profound in its implications, delicately weaves the intricate story of structural resilience and engineering marvel, underpinned by the awe-inspiring design of the Twin Towers. The towers were never designed to withstand the kind of damage they experienced on that fateful day. The architects and engineers had, at most, envisioned a scenario where an errant aircraft might accidentally collide with the structures. The fires, if they ever happened, were expected to be confined to a single floor, with the sprinkler systems efficiently dousing the flames. Yet, on that day, the reality painted a starkly different picture. Key structural elements were obliterated in the blink of an eye, and roaring fires engulfed several floors simultaneously, with the sprinkler systems in ruins. Despite this, the towers stood, albeit briefly owing to their redundant weight-bearing mechanisms. Imagine the towers in your mind, the exterior walls with their narrow windows, flanked by tightly spaced steel columns, deep beams at the floor levels forming a tight lattice of steel that sheathed the buildings. This lattice was not assembled on site. Instead, it comprised 3-story tall by 3-column wide panels, fabricated off-site and transported to downtown Manhattan. These panels were staggered vertically to enhance the overall strength of the structure. The 4 sides of each building formed a tube, interspersed with window slots. This tube bore the weight of the building and its contents, transferring it directly downward to the foundations. The walls, acting as vertical beams as wide and tall as the buildings themselves, bent to absorb wind loads. When the aircraft tore through the towers, eliminating rows of columns and beams in the exterior walls, the lattice above the damage sprung into action. The damaged exterior walls, now partially suspended from the structure above, formed horizontal beams several stories deep to bridge the gaping hole. The strength of the tightly spaced structural elements allowed the walls to sag without complete failure. This state of resilience allowed many occupants below the collision floors and in surrounding buildings to escape. In essence, the World Trade Center towers, in their short-lived resistance against the horrific attack, displayed a testament to architectural brilliance and structural resilience. The towers, though not designed to endure such damage, held up through redundant weight-bearing mechanisms, off-site prefabricated lattice work, and the inherent strength of closely spaced structural elements. These factors allowed the towers to sustain the impact and prevent immediate collapse, providing a window of escape for numerous occupants. Even in their demise, the towers stood as a symbol of human ingenuity and the relentless spirit of resilience. From the perspective of a structural engineer, the question arises, how can we design buildings to withstand such catastrophic events? The answer lies in 3 key elements: redundancy, advanced materials, and regular maintenance. Redundancy, or the principle of having multiple load-bearing elements, is crucial. As we saw in the World Trade Center towers, the presence of redundant weight-bearing mechanisms allowed the structure to sustain the impact and prevent immediate collapse. This concept is critical in designing structures resilient enough to withstand unforeseen disasters. Next, we must consider the role of advanced materials and technologies. The use of high-strength steel and concrete, innovative construction techniques, and advanced structural systems can significantly enhance a building's resilience. For instance, the use of off-site prefabricated latticework in the World Trade Center towers contributed to their ability to withstand the horrific attack for a period of time. Lastly, regular inspections and maintenance are vital to ensure a structure's longevity and safety. By actively monitoring the health of a building, potential structural issues can be identified and addressed before they escalate into catastrophic failures. In conclusion, with careful planning, innovative design, and regular maintenance, we can enhance the resilience of our structures against unforeseen disasters. As structural engineers, we have the responsibility and the power to ensure the safety and durability of our built environment.